So we're now going to take a look at the homework from section 4.4, complex numbers, and also 4.5, fractional equations. That's where we are right this minute. Homework review for section 4.4. And we start with a problem on page 51, and it's problem 2b. 24p to the fourth divided by 7ps to the second. 7ps to the second divided by 9p to the third, 9p to the third, divided by 8s to the fifth. All right, so first of all, this is called a complex fraction, not a complex number. That's a different concept. A complex fraction is a fraction within a fraction. So the idea is to get rid of both of these denominators at the same time. So we need to multiply by 7. You don't need that. Get myself in gear here. Give me a few minutes to get myself in gear. So 7, we need to multiply by 8. We need to multiply by 7. We need to multiply by 8. We have a p here. There's nothing there, but we certainly need a p over here. And we have an s to the second, s to the fifth. So we use s to the fifth. You always use the highest one. Okay, so that's what we're doing. Now you need to cross stuff out. So 7 crosses out with the 7. P crosses out with the P. S to the second goes into S to the fifth, S to the third times. So 5 minus 2 is 3. And now let's do it down here. The 8's drop out, S to the fifth, S to the fifth, and we're left with the P. So from here, the next step is to multiply 24 times 8. Now, I'm not going to do that. I'm just going to put 24 times 8 because you never know what could cancel out along the way. P to the fourth and S to the third. 9 times 7 times P to the fourth, and that's it. That's it. Okay. So what can we do now to cancel out a little bit? Well, you could certainly cross out this. That's about it, I think. Otherwise, it's 8 times 24, which is 160, 192, s to the third, divided by 63. Oh, you know what we could have done? Let's do it. You know what we could have done? We could have divided 3 into 9 is 3, 3 into 24 is 8. So you should try to do stuff like that. So this is 64 s to the third over 3. 3 times 7 is 21. This is the answer to the question. All righty, so that's that problem. And we go on to 51D, 51 problem 2D. And this is what that looks like. X squared minus 36 divided by 12 divided by x plus 6 over 6. So let's first get rid of the denominators, then we'll deal with, if any factoring that has to go on. So we could multiply by 12 And this will give us 12 into 12 is just x squared minus 36. 6 into 12 is 2, so that'll be 2 times x plus 6. And this, of course, is x plus 6, x minus 6, divided by 2 times x plus 6. And you could see that now this cancels out, and we're left with x minus 6 over 2. That's the answer to the question. Okay, so now let's go to page 52, and that's going to be problem F. So 1 over a plus 1 over 1 over a squared minus 1. This is a really, really interesting problem. But let's go about it in the same exact way that we were doing the other problems. Okay, so in other words, let's assume there's a denominator of 1. We're going to multiply this entire everything here by a squared. Once you determine the least common multiple, you multiply every term by the least common multiple. So let's do this. So a into a squared is a. And then 1 into a squared is just a squared plus a squared divided by, this cancels out, and we're left with 1 minus a squared. Okay, now it seems to me this could be factored up here, so let's do that. And we get a times 1 plus a divided by, and let's factor that, 1 minus a and 1 plus a. And you can see where this is going, right? Let me just, as I'm going along, I'm checking. And now cancel this out. And I believe the answer is a over 1 minus a. Problem H. 1 over x plus 3 minus 1 over x minus 3, 1 over x plus 3 minus 1. Okay, well, so we need to multiply by the least common multiple, will be a combination of all of these denominators. So we're going to multiply so the LCD, in other words, in this case, is x plus 3 times x minus 3. Okay, so every term gets multiplied by x plus 3, x minus 3. Let's use this one. Let's use what's already there. Let's kind of cheat a little bit here and use that to multiply. And then here, x plus 3, x minus 3, and x plus 3, x minus 3. Okay, now let's begin. And we put the answer over there. So this cancels out with that, and you're left with x minus 3. Okay, that's good. And then this cancels out. Whoops, that's not, I shouldn't have done that. Okay, x, this is what I erased, but I want to keep that there. Now work over here. So this cancels out with this, and I get so wait a minute, this is from the previous. That don't forget that minus, right? That minus x plus 3 over there See, I crossed that out, so I have this left. And then divided by, let's see, this cancels out with that, x minus 3 minus, and this will be x plus 3 times x minus 3, because there's nothing there. So this is kind of interesting. Let's keep going though. X minus 3, now minus x minus 3 divided by x minus 3 minus x squared minus 9. Okay, remember, so here we're multiplying two conjugates and we wind up with a difference of two perfect squares. So that's kind of interesting. And now the x's drop out because x minus x drops out. You're left with -6 in the numerator. And in the denominator, x minus 3 minus x squared plus 9, -6 over, well, I mean, if you put the negative x squared in front, plus x plus 6, it looks like that's the answer. I mean, if you want to factor out, is this right? Has anybody done this? Somebody must have done the homework. What? Go ahead.
Isn't +9 not +6? Negative x squared plus x plus 9? And then you factor it or you don't factor it?
Say it again. Over here. Are you talking about here?
No, you wrote as the answer negative x squared plus x plus 6.
Oh, that should
-3 plus 9. I'm sorry, I didn't see that. I see. Do you not factor out the negative x squared plus x plus 6 because of a negative?
factor out the what?
Do you not factor out the denominator of the final answer?
What can I factor out? Well, you know what I'm going to do? I'll tell you what I'm going to do. I'm going to factor out a negative. I'm going to multiply the entire fraction by -1 over -1. And we got 6 over x squared minus x minus 6. That still doesn't do anything for me, though. Like, how does that help to simplify? I mean, this can be factored now. Now it's obvious this can be factored into x minus 3, x plus 2. But, I mean, it still doesn't do anything. That's the answer. That's it. I don't see anything else that we could do in this problem. The x's dropped out here. The -3 became -6. X minus 3 minus x squared plus 9. Forget it. It's just that's it. I don't see anything else that can be done. Let's move on. These complex fractions are well named, don't you think? All right, this is the last problem with complex fractions. And if I remember correctly, it's quite a humdinger. You know that expression, humdinger? This is 3b. So here's the problem. I'm going to write small. Let me go down here, okay? So m plus 2 over m minus 2 plus, I don't know why I put parentheses because I may not need that, but I'll just kind of put that there. M minus 2 over m plus 2. All right, so I'm going to multiply everything by m plus 2 times m minus 2. M plus 2 times m minus 2. M plus 2 times m minus 2. And m plus 2 times m minus 2. All right, so according to that, we can cancel this out with this, and we get m plus 2 times m plus 2 plus the m plus 2's cancel out, and here you get m minus 2 times m minus 2, m minus 2, m minus 2, plus this cancels out with that, m plus 2 times m minus, excuse me, plus 2. Okay. I think that's what's left. Doot, 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 okay. Doot, 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 doot. That looks right. Believe it or not, this is what it is. Now I'm going to multiply a million binomials. Get ready for this. M squared plus 4m plus 4 plus m squared minus 4m plus 4 divided by m squared minus 4m plus 4 plus m squared plus 4m plus 4. Now, with any luck at all, stuff will drop out. So let's see, can anything drop out here? These can drop out. These could drop out. Isn't that interesting? All right, so what we wind up with is m squared plus m squared plus m squared plus 4 plus 4. Let me just start simplifying as I go along, rather than simplify at the end. So the m squared plus the m squared is 2m squared plus 8 over 2m squared plus 8? Are you kidding me? You mean it's all equal to 1? Now I'll move on to chapter 4.5, which is fractional equations. For example, on page 56, problem 1b, y over 6 equals 4 minus y minus 1 over 12. So, to get rid of the denominators, we multiply by the least common multiple, which, is 12. So 12, 12, and 12. Beautiful. 6 into 12 is 2. 2y equals 1 into 12 is 12 times 4 is 48 minus, now watch it. Watch it. Don't, you got to be careful with that minus sign there. So that's what I did to take care of that situation. And then we get 2y equals 48 minus y plus 1. Okay. And then 2y equals 48 and 1 is 49 minus y. Bring the y over. 3y equals 49. Oh, well, you can't have everything, right? And this becomes y equals 3 into 49 goes 16 1/3. All right, let's go on. Problem F. Let's put F down here because I don't know if we're going to have room. So 3x plus 1, 3x plus 1 over 4 minus 7x minus x squared over 10 equals x squared minus 1 over 8. So the least common denominator, least common multiple, I should say. We're not using it really in the context of a least common denominator. Least common multiple is a number that everything will go into. So it's not going to be 20, it'll be 40. I think 40 is the least common multiple, right? So 40, 40, and 40. Okay, so 4 into 40 goes 10. 10 times 3x plus 1 minus 10 into 40 is 4. 4 times 7x minus x squared. And 8 into 40 is 5. 5 times x squared minus 1. Okay, and now 30x plus 10 minus 28x plus 4x squared equals 5x squared minus 5. Now let's combine like terms over here. That's what we do now. That's what we're going to do now. Let's see how we could do this. We have like terms here and here. So let's put it in order. Let's put it 4x squared plus 2x, 4x squared plus 2x plus 10 equals 5x squared minus 5. Okay, now what do you want to do now? Let's bring this over here. I know I like to usually bring things to the left, and really it doesn't matter, but negative 4x squared, and let's make this negative 10 and negative 10. And what we wind up with is 2x equals x squared minus 15. Bring over the 2x. And now we can turn it around. X squared minus 2x minus 15 equals 0. Okay. And it turns out we could factor this. Is quite a problem, huh? Negative and positive x equals negative 3, x equals 5. Do we need to check for extraneous solutions? That's the question. Why don't we have to check to see, using this solution, if this equation has if either one of these two are extraneous solutions? Why isn't that necessary here? Because if we substitute, because these are the denominators, regardless of anything that happens in the numerator, it's the denominator that would give us extraneous solutions, because we would have 0. The only thing that would make an extraneous solution in this type of fractional equation would be if there was a 0 in the denominator. Neither one of these solutions will cause a denominator of 0, mainly because the denominators are 4, 10, and 8. So the only thing that could become a 0 would be a numerator, but we don't care what the numerator is when we're talking about fractions. We only care that the denominator is not equal to 0. And that's the reason. That's more or less the explanation I would have liked. Because we're not interested in the denominator, and the denominators are whole numbers anyway. It doesn't make a difference. And even if we substituted in the numerator and got a 0, it wouldn't make a difference, because we don't care what the numerator of a fraction is. We only care about the denominator, and that's the reason. Next problem. And this problem is very important. So let us go back up to the top. So x over x plus 6, x over x plus 6 equals 72 over x squared minus 36 plus 4. Here's the next question. Based on what I said, do you think in this problem we're going to have to check for extraneous solutions?
Yes,
Why?
because the denominators can't equal 0.
Right, because we may have a problem here. If x is equal to -6 or even +6, we're going to have a problem. So beware of the 6s in this problem. Otherwise, we'll be okay. But if we have a -6 here, or a +6 here, or a -6, because this will be 0, then we have a problem. So, okay, so thank you, Shayla. Now, let's rewrite the problem, because we would like to keep the pristine nature of the equation. And let's actually factor this. That may help us to find the common denominator. So the common denominator will obviously be x plus 6 times x minus 6. And here, x plus 6 times x minus 6. And here, x plus 6 times x minus 6. Okay, so this cancels out with that, and we're left with x minus 6 times x. Don't forget the x. So x times x minus 6 equals, both of these drop out, 72 plus 4 times x plus 6 times x minus 6. Let's multiply out. So here we get x squared minus 6x equals 72 plus, now let's keep this back. Let's put this back to its original form. So originally it was x squared minus 36. So let's keep it like that as we now multiply 4 times x squared, and 4 times 36, I believe, is 144. If I'm not mistaken. I could be mistaken. I know 2 times 36 is 72, so 72 times 2 is 144. Okay, so let's bring stuff to the other side of the equation, shall we? Whoop. Whoa. There's no just plain old ordinary x's in this problem? That's the only one? Okay. I think what we better do is bring everything to the other side of the equation. Okay, and here we get, well, actually, wait a minute. I'm sorry, my apologies. We didn't combine like terms to a sufficient degree. So let's combine these two like terms. So this gives us x squared minus 6x equals 4x squared minus 72. Okay, and let's now bring this over here, bring this over here, bring this on the other side, and we wind up with negative 3x squared minus 6x plus 72 equals 0. And now we could factor out, if I did this correctly, which I'm not totally sure. Let me go back and check. All right, that's a good way of determining if I did this correctly. I think I did. I don't see any reason why I shouldn't think that. Factor out a negative 3, And that'll leave us with x squared plus 2x minus 36 equals 0. And let's get rid of this. So we're left with x squared plus 2x minus 36 equals 0. Ooh. Two numbers that multiply to give you 36 and add up to 2. I made a mistake in this problem. I just know it. I just know it. And I can't figure out where it is. Two numbers that,
Professor,
but
what happened to the minus 144?
yeah, I made that into I put the negative 144 together with the 72, and I got a negative 72. But then for some reason I changed, I brought it over there, and that made it positive, and then took out the negative, x squared, take the negative out, 3 times 2 is 6, and 3 times, well, that's a problem here. I see a problem. If you factor out a 3 from 27, you do not get 36. There's the problem right there. I found the problem. Okay, that's what the problem is. See, the problem was when I factored out the 3 into 27 into 72 is equal to 24. So this should have been a 24, and now you could factor it. And that's what the problem was. And this is now 6 and 4, positive and negative. X is equal to 4, and X is equal to negative 6. These are the two answers. Okay, so I found my mistake. When I factored out the 3, everything was going along very well because 3 into 3 is 1, 3 into 6 is 2, but 3 into 72, I did 36, but it was really 24. Okay, so that's what the problem was. And that permitted me to then factor it, and I got that as the answer. I'll leave you with the easy part of the problem. Are there any extraneous roots?
Negative 6.
Say it again.
The negative 6.
Okay, your microphone is a little off today, right? So, yes, why? Because when you go back up here to the top and you substitute negative 6 in the denominator, you're going to get 0, and that's the problem. So this is an extraneous solution. And the answer is simply x equals 4.